The sun is burning at 27 million degrees, so why is space colder than Antarctica? Almost absolute zero? Space is full of fire, literally. There are trillions of galaxies, each packed with billions of stars, all burning at extreme temperatures. And yet, space is incredibly cold. So today, we're answering a fascinating question. Right finger, why is space so cold? Even near the sun? This might completely change how you see the universe. Small diamond part 1. WHAT, temperature, really means before we answer the big question we need to fix. One common misunderstanding. Temperature is not about how something feels. It's about how fast particles are moving. Asterisk fast-moving particles equals hot. Asterisk slow-moving particles equals cold. Now here's the key idea. Right finger no particles equals no temperature. In space? It's almost completely empty. In 1 cubic meter of space, you might find just one atom. On Earth, that same space contains 25 quintillion molecules. That difference explains everything. Small diamond part 2. How heat travels. Heat moves in 3 ways. Number 1, conduction. This happens when objects touch, like a hot pan. Burning your hand. Right finger, but in space, nothing is touching. So no conduction. Number 2, convection. This is heat moving through fluids like air or water. Right finger, but space has no air. So no convection. Number 3, radiation. This is the only way heat travels in space. The sun sends energy as electromagnetic waves. But here's the critical point. Right finger radiation does not heat empty space. Right finger, it only heats objects it hits. So the energy passes through space, without warming it. Small diamond part 3. Why space is so cold. Now we can finally answer the question. Right finger, why is space so cold? Even near the sun? Because there's almost nothing there to absorb heat. The sun is blasting energy in every direction. But space itself doesn't hold that energy. Only planets, moons, or spacecraft get heated, because they have matter. That's why space remains close to 455 degrees Fahrenheit, nearly absolute zero. Small diamond part 4. Extreme temperatures. Iodine mononitride. Space. Here's where things get crazy. In space, you can experience extreme heat and extreme cold at the same time. Asterisk sunlight side. Up to plus 250 degrees Fahrenheit. Shadow side. Down to 250 degrees Fahrenheit, just a few feet apart. Why? Right finger, no atmosphere to spread heat evenly. Take the moon as an example. Asterisk day. Extremely hot night. Freezing cold. Same with spacecraft. They need both heating and cooling systems. Small diamond part 5. The strangest discovery, extended. Even though space looks completely empty and feels like a silent void, right finger, it's not truly empty. In fact, the universe is filled with something invisible, ancient, and incredibly important. It's a faint glow of radiation left over from the moment everything began. Right finger, the Big Bang. Milky Way. What is this mysterious energy? This leftover energy fills every corner of space. Scientists call it the right finger cosmic microwave background, CMB. Think of it like fire, the fading heat of a fire that burned billions of years ago. The fire is gone, but its warmth is still there. Thermometer. The temperature of the universe. This radiation sets the baseline temperature of space itself. Right finger, around 455 degrees Fahrenheit. About 2.7 Kelvin. That means, even in the deepest, darkest parts of space, far away from any star, right finger, there's still a tiny bit of heat. Ice, but here's the mind-blowing part. The universe is not static. It's constantly changing. Right finger, it is expanding. Right finger galaxies are moving apart. This discovery was first proven by Edwin Hubble. Snowflake in expansion has a surprising effect. As the universe expands, right finger energy spreads out, right finger radiation stretches, right finger temperature drops so slowly, over billions of years. Right finger, the entire universe is cooling down. Crystal ball, what does this mean for the future? If this continues, one day, in the far future, right finger stars will burn out, right finger heat will disappear, right finger, the universe may become a cold, dark place. This idea is known as the right finger heat death of the universe, a universe where snowflake, no light, snowflake, no warmth, snowflake, no life, just endless cold silence. Small diamond part 6. Real examples that prove it, extended. Now let's bring this idea closer to home. Right inside our own right finger solar system, because space being cold isn't just theory. Right finger, we can actually see it happening. Sun example 1. Mercury, closest planet to the sun. You'd expect it to be hot all the time, right? But here's the reality. Fire daytime. Approximately 800 degrees Fahrenheit, snowflake nighttime. Approximately 290 degrees Fahrenheit, exploding head. Why such extreme difference? Because Mercury has right finger almost no atmosphere, no air equals no heat storage, no air equals no heat circulation. So what happens? Right finger, the side facing the sun, heats up fast. Right finger, the side facing space, freezes instantly. Cloud example 2. Venus. Now look at right finger Venus, it's actually farther from the sun than Mercury, but it's much hotter. Fire, constant temperature. Approximately 900 degrees Fahrenheit, day or night, doesn't matter. Fire, what makes Venus so hot? Right finger, a super thick atmosphere. Right finger, dense carbon dioxide clouds. Right finger, extreme greenhouse effect, this traps heat like a blanket. It's like right finger wrapping the entire planet in a pressure cooker of heat. Balance scale, the big lesson. So what does this teach us? Right finger distance from the sun is not everything. Right finger atmosphere controls temperature. This is why globe Earth is special, because it has checkmark the right distance, checkmark the right atmosphere, checkmark the ability to trap just enough heat. Small diamond conclusion. Extended. So now you finally understand the real truth. Right finger, why is space so cold even near the sun? Brain, the simple answer. Because space is almost empty. There are crossmark no particles, crossmark no air, crossmark no medium to carry heat. Fire, the deeper truth. The sun doesn't heat space. Right finger, it heats objects. Like checkmark planets, checkmark satellites, checkmark asteroids, checkmark even astronauts' suits, but the empty vacuum? Right finger, it stays cold. Milky Way, a universe of extremes. This creates a strange reality. Right finger, the universe is not evenly warm, instead, it's snowflake, mostly freezing cold. Darkness, fire with tiny pockets of intense heat. Stars are like right finger, small campfires in an endless frozen wilderness. Globe, why Earth is incredibly special. Out of all this cosmic chaos, Earth stands out. Because here, everything is balanced. Checkmark perfect distance from the sun, checkmark protective atmosphere, checkmark heat retention, checkmark liquid water. This balance allows right finger life to exist, right finger humans to explore, right finger you to even ask this question. Rocket final thought, the next time you look up at the night sky, remember, right finger, you're not just looking at stars, you're looking at snowflake, a cold, expanding universe, fire filled with tiny islands of heat, and somehow, right finger, you're living on one of them. If this changed how you see space, if it made you realize how strange and incredible our universe really is, right finger hit like, right finger subscribe, right finger turn on notifications, because there are still countless mysteries out there. Black holes, dark matter, parallel universes, and trust me, right finger, this is just the beginning. Rocket.